dive. Today we are going to be diving into quantum computing. And this is a technology with, wow, just so much potential. It's kind of hard to wrap your head around it all. And you've clearly been doing your homework. We've got some really fascinating research lined up for this deep dive. I am excited to unpack all of it with you. So we'll break down exactly what quantum computing is, why seemingly everyone is so hyped about it, and what challenges still lie ahead.
Yeah, I'm ready to jump in. It's one of those fields that seems to be, changing every single day, and the implications are definitely significant, if not staggering.
Okay, so to set the stage, maybe we could do a really quick recap of how our everyday computers, actually work. We've got bits, those trusty zeros and ones, and you can kind of think about it like a light switch. It's either on or off, just like a one or a zero.
Exactly, exactly. But that's where quantum computing really throws us a curveball. So instead of bits, it uses these things called qubits. And they're like, well, imagine that light switch can be on, off, or both at the same time.
Wait, hold on. Both at the same time. That's not just like a dimmer switch. That just seems like we're breaking some fundamental rules.
Yeah, exactly. It's like we're breaking all the rules. And the way, or I guess the reason that they can even do that is because they get their power from quantum mechanics. And as you know, that's the set of rules that governs the subatomic world. It's almost like stepping into, what's that book, Alice in Wonderland. Things just behave totally differently down there. And, this being in multiple states at once is called superposition.
So it's not that these particles can't make up their minds. It's that they're embodying all the possibilities at the same time.
Okay.
Okay, that's wild. But how do we actually use that, harness that for doing actual computing?
Well, this is where another kind of mind-bending concept comes in, entanglement. So picture in your mind two coins being flipped at the same time. Now, in the quantum world, these coins are qubits. They can be linked, and this is the crazy part. They can be linked so tightly that even if you flip them miles apart, knowing the outcome of one instantly tells you the result of the other one.
It's like they're magically connected or something. You said it yourself. This is strange territory we're venturing into. This is wild.
Stranger than fiction, I think, sometimes.
Yeah.
But, and this is key, that entanglement is key to unlocking the true power of quantum computing.
Okay, so I'm starting to see why everyone's calling this a technological revolution. But let's talk about some applications. What can we actually do with quantum computers that our current computers just can't handle?
We're talking about being able to tackle problems that would take, the computers we have today, billions of years to solve, if they could even solve them at all. I mean, just imagine cracking the encryption that's protecting your online banking, or developing medicines that are personalized just for you based on your genes, or even something like modeling the complex systems that control the climate and being able to do it accurately.
Okay, well, I really want to dive into those applications because that's where things get really exciting to me. Let's start with cryptography. You were saying something about unbreakable codes.
Yeah.
How would quantum computing change the game there?
So right now, most online security relies on, math problems that are really, really difficult to solve. Even for the best supercomputers. It's not that they're theoretically impossible to crack with our computers today. It's just that, it would take so long, it's basically impractical. But a quantum computer, if it were powerful enough, could potentially break these codes way, way faster. And, well, that's because of the way they process information.
That honestly just sounds like a recipe for total cybersecurity chaos.
It's definitely a double-edged sword. While it's true that quantum computers could be a threat to, all the ways we do encryption now, they also hold the key to being able to build new systems that are, well, vastly more secure. Like, imagine a world where all your data online was protected by the laws of quantum mechanics.
Okay, so it's like a whole new arms race, but for cryptography, and the stakes are way, way higher. That's kind of terrifying, but also really exciting at the same time. But let's move on to something a little less ominous, maybe. Something like drug discovery. How could this revolutionize how we develop new medicines?
Just imagine being able to simulate the interactions between, like, a drug and the human body, but at the molecular level. Like seeing how they interact atom by atom. Then, instead of spending years doing lab work and clinical trials, we could use those quantum simulations to design drugs that are hyper-targeted, tailored to someone's specific genetic makeup.
Wow, so you could get rid of side effects and create treatments that are just incredibly effective. That's like personalized medicine on a whole other level.
Exactly. We could be talking about potentially curing diseases that are basically a death sentence right now. Alzheimer's, Parkinson's, even certain cancers. These are all diseases that could be eradicated if we can make quantum simulations a reality.
That's the kind of future I want to be a part of. Now, how about climate change? I read that that's a major area where this could all make a huge difference.
Oh, absolutely. Climate change is just this monstrously complex problem. And to have any chance at really combating it, we need to understand how all of our planet systems interact, but at a much deeper level than we do now. And quantum computers, they could analyze climate information, massive, massive data sets. They could run really complicated simulations that even the most powerful supercomputers could never handle.
So we'd be able to create much more accurate climate models, allowing us to actually make better predictions about the future and come up with better solutions to, mitigate climate change and fix things.
Exactly. It would be like having a crystal ball for the entire planet. But, crystal ball that was rooted in actual science and computational power.
This is all just so incredibly promising, but I have to imagine that building and maintaining these machines comes with like a whole other set of challenges. It's not just snapping your fingers and having a quantum computer appear, right?
You're totally right. Building a quantum computer, it's kind of like trying to, I don't know, build a house of cards but in the middle of a windstorm. It's that delicate. The qubits, they're incredibly sensitive to anything, any kind of disturbance from the outside world, even something as small as like a vibration or a tiny temperature fluctuation that can totally disrupt their quantum states.
So how do you even begin to build a machine that sensitive? It seems impossible.
It takes some really, really innovative engineering, that's for sure, and a deep, deep understanding of quantum mechanics. Right now, it's like the tech giants, Google, IBM, Microsoft, they're all in this race to build a quantum computer that's actually practical. And the techniques that they're using are incredible. Imagine having to isolate these qubits from the rest of the world,
Yeah.
shielding them from any kind of interference. It's like creating this miniature quantum sanctuary.
Now, I remember reading something about Google claiming to have achieved quantum supremacy. What does that really mean, practically speaking?
Yeah, that was a big deal. It was a huge moment. Basically, what they did was they showed that their quantum computer could solve a very specific problem, and they did it way, way faster than even the most powerful supercomputer could. Think like a few minutes versus thousands of years.
Wow. Yeah, okay, that sounds like a massive leap forward. So does that mean we're on the verge of having these things in our homes and workplaces?
Not quite. We're still very much in the early stages. What Google did, while impressive, was more of a proof of concept. We still have some major hurdles to overcome before quantum computing is something that everyone has access to.
Like what are the biggest challenges holding this technology back?
One of the biggest ones is something called quantum decoherence, and it's a mouthful. Basically, qubits, they tend to lose their quantum properties over time. It's like they get tired of being in multiple states at once, and they just want to collapse into a single state. Kind of like a boring state, really.
So they're like the ultimate multitaskers who suddenly decide they can only focus on one thing at a time.
Ah, that's a great way to put it. And the longer a qubit has to hold on to all those different states, kind of like spinning all those planes at once, the more likely it is to just drop everything. And this decoherence, it's a major roadblock for building quantum computers that are stable and reliable.
So how do researchers plan on dealing with this decoherence problem? Like how do you tell a qubit to, I don't know, hold on to its quantumness for longer?
Well, this is where it gets really, really ingenious. Scientists are developing something called, get this, error-correcting codes. Basically, these are algorithms, very sophisticated algorithms, that can detect and correct those little errors that pop up because of this decoherence.
So it's like having superpowered spell check for a quantum computer.
Yeah, exactly. And these error-correcting codes, they're crucial because they'll let us build quantum computers that are way more powerful and reliable. Even if the qubits themselves are still kind of leaky, you know what I mean, when it comes to how long they can hold on to their quantumness.
This is just incredible. It really sounds like we could be on the verge of a technological revolution that will change the world in ways we can't even imagine. What stands out to you as the most significant part of this technology? It's almost like we're not just building some new machine, but we're actually like changing how we see reality. It really makes you think about everything we know about, well, everything.
It definitely challenges, everything we thought we knew. I mean, for centuries, we've just operated under this assumption that, well, that the world works in a certain way, right?
Yeah.
That cause and effect are always tied together,
Mm.
or that things can only exist in one state at a time.
Mm.
And then quantum mechanics comes along and says, nope, think again.
It's like we're stepping into, what was that book? Alice in Wonderland, a world where anything is possible. And what's amazing is that with quantum computing, we're not just watching this stuff happen, we're actually using it to solve real problems.
It really is a totally new way of thinking about things. And it makes you wonder, what else don't we know? What else will we discover about, well, the universe, even ourselves, as we learn more about this quantum world?
It's exciting, but it's also kind of scary, right? Like we're right on the edge of something huge, but we don't really know where it's going to lead.
Exactly.
Yeah.
Exactly. This is just the beginning, and I have a feeling it's going to be full of surprises.
Well, there you have it. That's our deep dive into the world of quantum computing. It's a field that has the potential to revolutionize pretty much everything. We're talking medicine, materials, how we keep our information safe online, even modeling climate change. And maybe, just maybe, it'll help us understand reality itself a little bit better.
And who knows what we'll discover along the way. I think that's what's so great about all this. The possibilities really are endless.
That's right. It's one of those fields where you just have to keep asking those big questions and never stop exploring. Thanks for joining us on this incredible journey into the quantum realm.